Okay, so on example 1, we have f is a sinusoidal function, and we want to know the period. What do y'all think? What's the period? 2. Oops. So from here to here is a sine curve that occurs in a unit of 2. Okay. On example 2, we could go through that process we've been doing to find c, like kind of algebraically, methodically. It works out kind of iffy. So let's just think about shifting a cosine function. And so let's draw a cosine function that would be this if I just dropped off all the addition and subtraction. So we're going to draw y equals cosine of 2x. What would the amplitude be? 1. So the amplitude comes from what's in front of the cosine. And then what would the period be? The period is going to be 2 pi divided by 2, or just pi. So we're going to draw a cosine graph that has an amplitude of 1 and a period of pi. Right? And then we're going to take it and we're going to shift it so it matches this graph. And this cosine graph, and that's not something we've talked about, it's going to repeat this pattern over and over. Oops, I'm going too low. In both directions. It's going to keep on going over and over and over and over and over again. The same pattern. All right, so what we know is that it's shifted down 1, which you can see that obviously it's shifted down 1. We're trying to figure out the value of C that is going to match it up. The dotted one would match up with the solid one. Is there any way it's 0 where it's not shifted at all? No. So forget about that one. So all of these are positive values that you would put in for C. What direction is that going to make it shift? Left or right? Left. These are all left shifts. All right. So which one, like we're obviously going to shift down, which one of these values, if we shifted left that much, is going to put it on top of it? Pi over 2. All right, so we can take this point right here, shift down 1, and left pi over 2, and that's the graph. Does that make sense? Okay, we probably should have started off with ones like that before we bumped into the ones where you're doing everything. Okay, now Brian Passwater really likes these questions. This one is a yo-yo. On the homework, I think it's like a game show spinner or something like that. So I had to read it a few times to understand what he was really talking about. So I'll read it slowly, and you can read along with me. But a yo-yo that is attached to a 30-inch long string is rotated at a constant rate. And so here's where the yo-yo starts, is rotated around in a circle. Everywhere on this circle is 30 units away from 0 because that's the length of the string. All right, so the figure provides representation of the yo-yo in the xy plane with the direction of rotation indicated. At time t equals 0 seconds, the yo-yo begins to rotate. The yo-yo is at the start position in the figure. At time t equals 5, the yo-yo has completed 20 rotations and the yo-yo is in the same position as it was at time t equals 0. A sinusoidal function is used to model, this is important, the x coordinate. All right. So sometimes it tells you it's used to model the x coordinate. Sometimes it tells you it's used to model the y coordinate. So pay attention to that because it changes from problem to problem. The x coordinate of the position of the yo-yo as a function of time, t in seconds. Which of the following is an appropriate model? Okay, so what I'm going to do over to this side is I'm just going to do a graph of what they're talking about. So this graph that we're about to draw represents the position, the x coordinate of the position of the yo-yo. So at time t equals 0, what is the x coordinate there? the x coordinate? 0. So we're going to start off at 0. All right, it's rotating around this direction. And so as we're rotating, is your x positive or negative? Positive. What is the highest value of the x coordinate? 30. And so what's happening at the beginning is it's increasing until we get to 30. I drew that wrong. Sorry, hold on. So we get to 30. All right. And then as we go around, is your x still positive? Up here, the x coordinates? Yes. But they're getting smaller until they get to 0. So here we go. We're going to get to 0. Right here. All right. And then what about the x's? They're negative. What's the lowest x coordinate we're going to get to? Negative 30. And then we're going to go back to 0. What kind of curve does that look like? That's a sine curve. Now, this one, that all the answer choices are sine. On some of them, there'll be a combination of sine and cosine. So I always at least kind of do a little sketch. You don't have to be super specific about the 30 and the negative 30, but at least do a little sketch to like comprehend what you're doing, especially if you're a visual learner like I am. All right. So all of these are sine. All of these have an amplitude of 30. So it's really going to come down to the period. So what it tells us in the problem is that 5 seconds, the yo-yo has completed 20 rotations. So 20 rotations in 5 seconds. Does that sound like a period or does that sound like a frequency? That is a frequency. And I would reduce it down to 4. So these are always, they're worded differently. Sometimes they give you a frequency, sometimes they give you the period. So if we know the frequency, what is the period? This is going back to the first day. It's going to be the reciprocal, so it's going to be 1/4, the multiplicative inverse. Okay, so at this point, you have 2 options. You can use the formula to find the period that you take 2 pi and you divide it by b. So 2 pi divided by the coefficient of t. So in this case, the coefficient is 1/4. Or you can go through that process that we've been doing and just find what b is. So you can take these choices and take 2 pi and divide them by the choices until you get 1/4. Or you can just find b algebraically by saying that 1/4 is equal to 2 pi over b. I don't know which one's easier for you. It's up to you. Either way, what's b going to be? 8 pi, right? So which choice D? All right. Any questions? I felt like I just had a million words. Okay. Let's look at example 4. This should sound familiar. We definitely have worked with this situation. A clock is mounted on a wall, and the point P is located at the tip of the minute hand of the clock. And the function h represents the height of point P from the ground at time t, where h of t is a sine function. And then we know that the points h of 0 equals 70 and h of 30 equals 52 is a maximum and a minimum. And so what we want to do is find A and D. So like I've told you a million times, I need to see this. And so what I know is when the t value is 0, we're up at 70 at a maximum. And when the t value is 30, we're at 52 for a minimum. So that's a portion of it. So D is what's going to fall directly in between those. And we've done this many, many times. I hope you guys already know how to find D. You're going to do max plus min y divided by 2. And so that's going to be 61. What about A? A, you probably can just do it in your head. What's A? 9. It's the distance. I'll write it down though. It's the distance between the max and the middle. That looks like A equals A. All right. Y'all good? Okay. And we're going to do one like example 7. You've had some of these on your worksheet, but they have, up until now, they have all been the simplest way to figure out. This one, I made it as difficult as I possibly could. So we're going to do it together. So then when you do one on your own, it's going to seem way easier. All right. So on this one, the ones we've been doing, you can find the max and the min by taking, you can do the max by taking D and adding A to it. And you can find the min by taking D and subtracting A from it. All right, so our max is going to occur at 86.9, and then our min is going to occur at 35.5, which doesn't match A or C. So this is going to be one of the ones where we need to find where the max occurs or where the min occurs. Okay. And so we've talked a ton about the parent sine function and where the max occurs on it. So just to reiterate, what is the period of the parent sine function? Oh, I really want y'all to know this. We haven't talked about it enough, but it is 2 pi. So the period of the parent sine and cosine function is 2 pi. And so halfway between that is pi. Halfway between here is pi over 2. That's where a max occurs on the parent function. What about halfway between 1 pi and 2 pi? 3 pi over 2. That's where the min occurs on the parent function. So if we're looking at this, and I did change this from the original notes. Whoops. Both B and D say the minimum occurs at M, blah, blah, blah. So we're going to just find where the minimum occurs. If it had been maximum, that's like what we've been doing on all those ones where we're trying to figure out what C is. And we set this part equal to pi over 2 because that's the maximum. Well, what do you think we set it equal to if we're looking for a minimum? 3 pi over 2. All right, so that's what we're going to do. We're going to take pi over 6 times m minus 4 and set it equal to 3 pi over 2. And we're going to solve that for m, and that should be where the minimum occurs for this transformed function. What would you guys do first? Multiply by the reciprocal. Good. So it's 18 over 2, or 9. All right, and so m is 13. Well, that's a little bit of an issue, because if I had read this problem, you would see that this gives the average monthly temperature for m's between 1 and 12. Well, 13 is not in between 1 and 12. There's not 13 months. So our choices are 1 month and 7 months. So if we're thinking about this sine being a cyclic function that repeats the same thing over and over again, what month do you think corresponds with the 13th month? 1 month, yeah. So 13 13th month cycles back to month 1. Like I said, I tried to think of anything that could possibly happen on these types of problems, and I put it in this so you could, if you see it again, you would know what to do. Most of them, you are not going to have to do it. Most of them, doing this right here gives you the answer. Or when you solve it for this, it gives you either 1 or 7, and you don't have to think about the cycles. But I wanted you to be prepared for anything. All right, what questions do you guys have on that? Okay, this last question is a calculator question. So the function n gives the number of nighttime hours on the first day of a given month, where the month is between 1 and 12. The table gives the values of n at selected values of t, and we have a sinusoidal regression that gives the sign, obviously, with 16 iterations. So when you start doing this, you'll see where you need to put that 16. Is used to model these data. What is the maximum number of nighttime hours predicted from the sinusoidal function? Okay, so go ahead on your calculator, go to stats, and put this data in. So stat, edit, type it in. Everybody should be typing, not watching basketball on their phone. Now you guys know I like to store these regression equations in y equals 1 or y1. For some reason, the sinusoidal won't do that if there's something in there. I don't know why. So you just go to your y1 and clear out anything that's in there. All right, and then we're going to do stat. We're going to go over to calc and then start scrolling up. Scrolling up, you might get there faster. When you scroll up to C, that's the sinusoidal regression. And then when you choose it, this iterations, it tells you there's 16, so we're gonna put in 16. I'm not 100% sure if it matters a ton what that is, but we're gonna do what it says to do. All right, and then we're gonna hit enter all the way down to where it says store regression equation. And we are gonna store that in Y1. And then we're gonna calculate it. There it is. You would put that A, B, C, and D in, and that would give you the regression equation for that data. Now, this question is asking us, what is the maximum? So what do you do with which of those variables to find the maximum? You add DNA. Good job. And when you add that, you get approximately 11.33, which is closest to 11. All right, what questions do you guys have? Learned a lot of new things this week, for sure.